Hello Yearites and welcome back to mathematics. In today's lesson we're continuing with our topic of measurement, and what we're going to be looking at is finding the area of special quadrilaterals. So in today's lesson we want to be able to find the area of special quadrilaterals and identify the area formula for three types of special quadrilaterals and apply them to find the area of different quadrilaterals. So let's get started. Now, last lesson, we started talking about the area of a few different shapes. And so in particular, we talked about the area of a rectangle and also a rectangle, a square, and also a triangle. What we want to actually do today is actually continue looking at this topic of area, or the space within a 2D shape, and have a look at a few more special, in this case, quadrilaterals. So what we want to be able to do is find the area of these following quadrilaterals. The first one we're going to be looking at is a parallelogram. Then we're going to be looking at a kite or rhombus, because they both have the same formula. And the final one is a trapezium. So let's have a look at these three shapes. The first one is a parallelogram. Now, a parallelogram is a quadrilateral, a four-sided shape, where the opposite sides are parallel. So if you ever look on this parallelogram, the opposite sides, they have an equal number of arrows going through it. So if you have a look over here, on my left-hand side, I've got one arrow going through, and I have one arrow on my right hand side, meaning they're parallel. And also the top and the bottom have the same number of arrows going through it, which means that the top and the bottom sides are parallel. And the other thing is that they're also, the opposite sides are also equal in length. I forgot to put that in as well. Now, with a parallelogram, the way that we find the area of a parallelogram is we need two particular measurements. First of all, we need this length here, the base length. And I'm going to call this B, so length of the base. And we need to then multiply that by the length of the height. And so in this case, this length over here, so height. Now with a parallelogram, we need those two specific measurements, and in particular we need to make sure that they're perpendicular to each other. So if you have a look in the little box between my B and my H, that just means that they're perpendicular. They meet at 90 degrees. And so when I try to find the area of a parallelogram, we just use the formula A is equal to B, let me write it in the colors that we have here, B H, or just B times H. So here, when we're trying to find the area of a parallelogram, we use this formula A is equal to BH. The area of my parallelogram is the base times the height. Now this is very similar. I'm just going to make a note here. This is similar. Oh, actually, I'll make it underneath. This is similar to the area of our rectangle. So similar to area of a rectangle. So if you have a look here, like we looked at last lesson, the area of a rectangle was just L times B. Here it's kind of pretty much the same thing, but we've got a few different letters involved, and just like we did with the rectangle, we just wanted the two perpendicular lengths. Okay, cool. So that's my first shape, the parallelogram. So if I want to find the area of a parallelogram, I'm going to need to use this formula here, A is equal to BH. Okay, let's have a look at the second shape. Now the second shape is actually two shapes at the same time, because they both have the same area formula if we use a particular type, if we find a particular thing. Now here, this is a kite or rhombus. So a kite is a two-sided shape where we've got two adjacent sides being equal in length, so those have the same number of dashes, and the other two have equal in length as well, so they have an equal number of dashes. And a rhombus is just the same as a parallelogram, and I realize I did this wrong. A rhombus is a parallelogram where all four sides have the equal length. So here, just like a special note to make, with a rhombus, if we get given the length of the base and the height, we can actually use parallelogram formula if given the base and the height. However, there's actually a second formula that we can use to find the area of my rhombus and my kite. So here, with a rhombus or a kite, if we get given the length of the diagonals. Now, diagonals are lines in your shape which goes from one corner or one vertex to another vertex where they're not next to each other. So for example, on my kite, if I draw this line over here, this is a diagonal. So here, I'm going to call this guy X, and my other diagonal is just the length between the other two, and I'm going to call this guy Y. And similarly, in my rhombus, I can actually draw two diagonals. So this one over here, this first one, I can call this one X. And my second one, I can call this guy Y. And if I get given these two measurements, to find the area of a rhombus using my diagonals, I can just use the formula. A is equal to half times X times Y, and so we just write that as half xy. So if we get given the diagonals of a kite or a rhombus, we can use this formula here to help me find the area of my kite or rhombus. Half times x and y, and so we need to make sure. So here, let me make a note. Make sure x and y are the diagonals. So we need to make sure that they're the diagonal lines that go across my shape. Okay, from opposite corners. Okay, that's the second formula that we need to know. And the final one is a trapezium. Now, a trapezium is it's a quadrilateral which has one pair of parallel sides. So these two lines, they are parallel to each other, and so that is my condition for a trapezium. And the area form of my trapezium, well, I actually need three measurements. The first one, I need the lengths of my parallel sides. So I'm going to call this one A. I'm going to call this one B. Nope. I need those two lengths. And the final thing that I actually need is the height of my trapezium. So just like in my parallelogram, I actually need this height, and we have to make sure it's perpendicular to my two parallel sides. So here I need my two parallel sides, A and B, my two parallel sides, and I also need the height of my trapezium. And if I want to find the area of my trapezium, then the formula is A is equal to, area is equal to half times the height times bracket A plus B. So for this particular area formula, what I need to do is I need to take my two parallel sides, A and B, add them together, which is what this bracket here tells me. Then I multiply that by the height and also times it by a half. So these are the three formulas that we're going to be using in today's lesson to help me find the area of special quadrilaterals. So the steps that we need to follow if we want to actually find the area of a special quadrilateral or any 2D shape for this matter. First of all, so the steps I have here. Firstly, identify the shape that you have. So have a look at the shape that you have and which one does it look like. Is it a trapezium? Is it a parallelogram? Is it a kite? Is it a rhombus? So the first step is to identify what shape you get given. The second step is then to just write the formula, write the correct formula. Now, if you have a look, we have our formulas up here, and you can actually, hopefully you've gotten a chance to copy those down. And if you haven't, you can pause it here and copy those down. All we're going to do now is then from there, just write down that formula that we have here. If it's a parallelogram, we're going to write down A is equal to BH. If it's a kite or a rhombus, we're going to write down A is equal to half XY. And if it's a trapezium, we're going to write down half AH, A plus B, bracket A plus B. Then, once we've done that, we're going to find the measurements that we need in that formula. So here, those colored letters, those are the measurements I actually need in all of my formulas here. So for a parallelogram, I need the base and the height. For my rhombus or my kite, I need my two diagonal lengths. And for my trapezium, I need the length of my two parallel sides and the height as well. And so then, once we've done that, we can substitute these values into the substitute the measurements into the formula, and then calculate the area by just figuring out what that number would be. So let's have a go at a few examples of finding the area of a few special quadrilaterals. So here, find the area of the following shape. So we've got three examples here that match up with our three shapes up there. So let's have a look at this. First one here, we've got this shape over here. Now let's have a look at the shape and figure out what type of shape it is. Well, if you have a look on this shape, we've got two pairs of parallel sides. We've got two pairs of parallel sides, which means that this shape is a parallelogram. And so what I can do is I can then write my parallelogram formula. A is equal to BH. So I'm going to write that down. A is equal to BH. Okay, and then all I need to do, I've identified the shape, I've written down the formula. Now, if you have a look at my formula, I need to figure out what sides I need, what measurements I need. So in this one, I need the base and the height. Now, if you have a look, even though they've rotated it, we just want to find the two measurements that are perpendicular to each other. So in this case, that's just going to be my 8 meters over here, and my 3 meters, which is the height, which is perpendicular to that. So here, my two measurements are 8 and 3 meters, and so I can just substitute that into my formula. Now here, what I said was, when we've got letters written together, for all of these formulas, we are actually multiplying. And so here, this just becomes 8 times 3, and it's also helpful to put in the units here. So here we've got meters, and because we're dealing with area, we have to write meters squared. So here, my formula was base times height. I figured out that my base and my height were 8 and 3, and so I need to substitute that into my base height formula, so I get 8 times 3, and I just wrote down the units meters squared. Then once we've done that, we just calculate that. 8 times 3 gives me 24, and so I'm going to get an area of 24 meters squared. So those are the steps that we need to follow if we want to find the area of these following shape, of a 2D shape. Let's have a look at the next example. This shape over here. I've got a shape, and if you have a look, they tell me that I've got two pairs of equal sides, and the equal sides are right next to each other. So that tells me that this shape is a kite. And so with a kite, I can look for my kite formula, which is half xy, and I need to make sure that x and y are my two diagonals. And so here, I'm just going to write that down. A is equal to half xy. And so here, if you have a look at the here, if you have a look at that formula, that tells me I need to find x, and y, my two diagonals. So if you have a look at the shape, they've actually given that to us. I've got 10 centimeters here, and the other length is this 20 centimeters, which goes from here to here. And so those are my two diagonals, and I can just substitute this straight in. So I'm going to get half times 10 times 20, and I'm going to put in a unit. Here, these measurements are in centimeters, so my area is going to be in centimeters squared. Okay. Then once we've done that, we just need to calculate what this number is. Now, when you do half times of anything, you're just halving a number. So for example, half times 10, you just give me 5, because half of 10 is 5. And then I need to times that by 20. And so here, I get 100 centimeters squared. If you're not sure how to do that calculation, you can just chuck this in your calculator, and the calculator can do it all for you. Okay, so that's my second example. Third and final example. Let's have a look at this shape. Now here we've got a particular shape, and if you have a look at the shape we get given, they don't tell us very many things about it, but if you have a look at the kind of shape it is, well, we can just have a look and say that this is a trapezium. And so with our trapezium, we need our trapezium area formula, which is half HA plus B. So here, I'm going to write down here, area is equal to half HA plus B. And so when I'm using this formula, I need to find the height, and I also need to find A and B, which are my two lengths of my two parallel sides. Now, if you have a look at this diagram, I've got 3, 5, and 11. I just need to figure out where all of these measurements fit in. Now, my two parallel sides happen to be 3 and 11. And so A and B are going to be 3 and 11, which leaves me with a height of 5. And so when I substitute this in, I'm going to write half times 5 times 3 plus 11 millimeters squared. So here all the measurements are in millimeters, so then my area is going to be in millimeters squared. Okay, so I can then start to calculate this. Now the first thing I need to do when I'm dealing with this is I need to deal with the brackets. So here I've got this 3 plus 11 in the brackets. I need to deal with the brackets first. So here I'm going to get 3 plus 11 is 14 millimeters squared. And then I can just put this in the calculator, or you can chuck the whole thing in the calculator to begin with, and you'll get an answer. I believe this should give you 35 millimeters squared as your final answer. So that's how we can find the area of special quadrilaterals using their formulas in different scenarios. So let's have a go. Let's just quickly talk about recap what we looked at in today's lesson. In today's lesson, we looked at finding the area of special quadrilaterals. And what we need to do for this is we need to actually identify what the formulas were for these special quadrilaterals. So for the parallelogram on our left here, we've got the area is the base times the height. For a kite or a rhombus, if we get given the two diagonals, the two lines that go across the shape, so from opposite corners to each other, the area formula is half x y, and the final shape was a trapezium where we needed the lengths of the two parallel sides a and b, and then the area formula was half h times a plus b. Then when we're trying to find the area formula using these using these area formulas, if we want to find the area of a 2D shape, what we need to do was firstly identify the shape that we have, secondly write down the formula for that shape. Then we need to find the measurements based on the formula that we get given, and then we substitute this into our formula and calculate that as a final step. And so we went through 3 examples of how to do this with our parallelogram, kite, and trapezium. So that's it for today's lesson, Year 8s. I hope that helped, and if you have any questions, feel free to send me a message. I'm more than happy to try and help you. But until then, I hope you guys are staying safe wherever you are, and I'll see you in the next video. Bye.